Hi guys, welcome to another episode of MrLopezClasses.com. This is the chapter 16 of your electronics books. Today we are going to talk about the marine GPS, and we are going to understand how the GPS, the marine GPS, is integrated with the autopilot system and is integrated with the radar. Those three elements work together: radar, autopilot system, and GPS. The GPS every day is the brain of the rest of the systems because the GPS have the information related with the location, the location with respect to the satellites, the location with respect to other element, to other object. This is critical. This is critical to calculate everything. For example, in your cell phone, without the GPS, it's not possible to use the majority of the functions that you have in your GPS. Those functions depend on the GPS. Depends where is you located in that moment, in that specific moment. The GPS is the vital component in the majority of the electronic devices that you have in your hand, in your home, in your car. Depend of this of the GPS. The GPS is the locator, is the antenna that is looking for satellites in order to verify where is your actual position right now. Okay, we are going to check what is the meaning of the GPS, and we are going to start right now. The GPS is the Global Positioning System. GPS, Global Positioning System. It's a space-based satellite navigation system that provides location and time information. Is maintained by the United States, and the only that you need is a GPS receiver. If you have the receiver, you have access to that information, and the most important is free. Free? No, because you need a provider, and you need to pay the monthly payment to the provider. What is your provider? Oh, my provider is AT&T, or my provider is Verizon, or depend of your provider. You paid in order to get access to the GPS. This is part of the business. The GPS program provides critical capabilities to military, civil, and commercial users around the world. All right, GPS on the world. The Russian global navigation satellite is GLONASS. GLONASS is the Russian global navigation satellite. Was in use by only the Russian military until 2007. There are also other GPS providers. The European Union have the Galileo position system. The Chinese use the Compass navigation system, and the Indians use the regional navigation satellite system. Those countries have your own satellite systems, and every day more countries and more companies, they have satellites located specific for those countries or those communication companies. Commonly used terms that we are going to use in this episode in order to understand the GPS and how the GPS works. Okay, we are going to divide the Earth in the middle. This line is the equator. Equator is the line which encircles the Earth at equal distance from north and south. In other words, it's the central line. If you cut it, the Earth in the middle is equal distance from the North Pole and equal distance from the South Pole. This is the equator. The coordinates, geographic coordinates, they are coordinate values given as latitude and longitude. Right now we are going to explain what is the meaning of latitude and what is the meaning of longitude. All right. Great circle. What is the meaning of great circle? It's a circle formed on the surface of the sphere by a plane that passes through the center of the sphere, the equator. The equator Each meridian and each other full circumference on the arms forms a great circle. What is the meaning of that? If you cut it, the Earth from the equator, this is the great circle. This is the biggest circle. And if you cut it other circles over or lower the center, the equator, those are other great circles. They are parallel to the equator. The arc of a great circle shows the short distance in between points on the surface of the Earth. Right now we are going to talk about that. All right. What is the meaning of meridian? Meridian is an imaginary arc on the Earth's surface from the North Pole to the South Pole. It's basically like this. If you have the Earth, and this is the North Pole, and this is the South Pole, it's an imaginary arc from the North to the South. This is a meridian. We are going to talk later that the name for those meridians is the longitude. Longitude. All right. Parallel. There are circles parallel to the equator. Okay, circles in the middle. Those are parallels. Parallels. All right. In other words, for example, if I have a circle, if this is the Earth, all right, the circle in the middle through the equator, this is the equator, and if I cut it, other parallels, those are parallels. Those are parallels. Those are parallels. And if this is the North Pole and this is the South Pole, those are meridians. Those are meridians. Those lines are longitude. And those lines parallel to equator are latitudes. Parallel to equator, latitudes. Latitude and longitude. We can imagine the Earth as an sphere with an axis around the axis in between the North Pole and South Pole, and the Earth is spinning around the axis. The end of the axis are the North and the South. The equator is a line around the Earth and with equal distance from North and South Pole. The equator is also the latitude, the equator, the middle one, this is the equator, is the line with the latitude 0 degrees, because it's located in the middle. The equator is the line with latitude 0. This is the explanation about the equator. All right, and yeah, the equator is a line around the Earth with equal distance from both poles. The equator is also called the line with latitude 0. What is the meaning of latitude? It's a line connecting all the points with the same latitude. This is a simple definition of latitude. This term is usually used to refer to the lines that represent values in whole degrees. Right now we are going to talk about that. All the lines of latitude are parallels to the equator. All the lines that represent latitudes are the lines parallel to equator. Those are parallels to equator. And they are sometimes also referred as parallels. Parallels are equally spaced because they are exactly at the same distance from the equator. Okay, there are 90 degrees of latitude going from north to south of the North Pole to South Pole, and they are located 90 degrees from the equator. There are 90 degrees to the south of the equator, and South Pole is 90 degrees S. All right, this is a 90 degrees line from the equator, because it's 90 degrees here from the North Pole. And there are another 90 degrees line here, 90 degrees from the equator into the South Pole. All right. And what is the meaning of longitude? Lines of longitude, called meridians, runs perpendicular to the latitudes. Let me return a little here. Those are the latitudes. Latitude 0. All the parallels are latitude lines. All the parallels are. And about the longitude are lines. Those lines are longitudes. Yeah, there are circles over there. Circles over there. Those are the longitudes. Lines of longitude called meridians. Meridians runs perpendicular to the latitudes and pass from south to north poles. Okay, the latitude 0 is the section that pass through the equator. The equator is considered the latitude 0. The latitude 0. Okay, perfect. This is the 0 for latitudes. Okay, there are parallels to the equator going to the north. Those are positive latitudes. And there are parallels to the equator going down to the south. They are negative latitudes. Perfect. How much is the separation between each latitude? Is in degrees, and right now we are going to talk about that. All right. And the same with the verticals, from north to south. Those lines, verticals, are called meridians or longitudes, and goes from north to south, perpendicular to the equator. The longitudes are perpendicular to the latitudes. The 0 latitude is the line passing through the equator. And the 0 longitude is a section in the middle passing from one city, Greenwich in England. That's the 0 line for longitude, Greenwich in England. For that reason, the people say, it's 20 degrees from Greenwich. Greenwich is the 0 longitude line, and equator is the 0 latitude line. Okay? Meridian longitude values are indicated the angular distance between the primary meridians and points east or west with respect to the central. Let me explain. This is the Earth, and this is the line of latitude 0, the equator. Latitude 0, equator. And this is the line of longitude 0, or Greenwich in England. Okay, all right. What happened with the parallels going to the North Pole? This is a parallel. How much is the separation between this parallel and this parallel? Okay, if I pass one radius from this point, and this angle is 7 degrees, this latitude is 7 degrees north. Let me pass other parallel to the equator, 7 degrees in the bottom. 7 degrees here in the bottom. This latitude is 7 degrees south, because this is the South Pole and this is the North Pole. This is 7 degrees and 7 degrees. This is north and this is south. What about this one? This latitude. This latitude, let me check. The angle here is 78 degrees. This latitude is 78 degrees north. Ah, what about this one in the bottom? Oh, this one in the bottom is 78 degrees, is 78 degrees south. This is with respect to the latitudes. And let me explain exactly the same. Let me explain exactly the same with respect to the longitudes. We are going to create another slide here, and we are going to talk about that with respect to the longitudes. Ah, okay. And those are the lines 0 latitude, and those are the lines with a 0 longitude or meridians. All right. And suppose that I have one element located here in this point. Ah, okay. What is the position of this point? Ah, is here. It's located in the latitude. Sorry, I make a mistake here. Suppose that I am talking about an element located here. Okay, this is the latitude 63. The latitude is 63 degrees north, and the longitude is the arc passing here. And that arc, if you check the Earth from the top, if you check the Earth and the top view, you remember our course of introduction. If you check the Earth from the top, the element in the previous picture is located here. From the top is located here. From the meridian is located here, all right, is 60 degrees north, and is separated 47 degrees, the longitude is 47 degrees east. Okay, what is the position of this point? The position of this point is 63 degrees north and 47 degrees east. This is the position, this is the latitude, and this is the longitude. And this is the longitude. Perfect. This is exactly the position. The latitude is parallel to the equator, and the longitude is parallel, is from north to south, parallel from Greenwich in England. Greenwich in England. Perfect. All right, this is the explanation about the latitude and longitude. Okay, there are also 180 degrees of longitude to the west of the primary meridian. When the directional designator is omitted, those longitudes give negatives. What is the meaning of that? Okay, if the element is located on this side, on the east, they are positives. On the east and at north, positives. Yeah? Okay. And what about if the longitudes are in this side, on the west? They are considered negatives. Okay. What is the meaning of that? This position is 63 degrees north, 47 degrees east, or 47 degrees positive. What about if this element is located exactly in the opposite here? The position of this element is 63 degrees north and 47 degrees negatives. Yeah, because it's located in the opposite of this. What about if this element is located here in the bottom? Okay, the position is 63 degrees south and 47 degrees, 47 degrees positive. If this element is located here, it's 63 degrees south and 47 degrees negative. Okay, because they are located in the bottom, or they are located in the bottom here, or they are located on top, positives. This is the explanation of that. All right. Degrees of latitude and longitude can be divided into minutes and seconds. Let me explain what is the meaning of that in order to be more specific. For example, if you have a coordinated, the coordinated is 65 degrees, 32 minutes and 15 seconds. What is the meaning of that? A degree of latitude is approximated 69 miles, and a minute of latitude is approximated 1.15 miles, and a second of latitude is approximated 0.02 miles. This is good idea. Depending of the separation from the equator, how is separated. You remember that in order to calculate this latitude, you send a radius here and you calculate this angle. In order to convert any latitude in degrees, minutes and seconds, this is the procedure. 1 degree of latitude is approximated 69 miles. 1 minute of latitude is approximated 115 miles. And 1 second of latitude is approximated 0.02 miles. 1 degree, 69 miles. 1 second, 1 minute, 115 miles. And 1 second, 0.02 miles. I need divided the total distance into degrees, minutes, and seconds according with this. 1 degree is equivalent to 69 miles. 1 minute is equivalent to 115 miles, and 1 second is equivalent to 0.02 miles. I have a good example. Suppose that I have a latitude separated from north, separated 320 miles. How much is that latitude in degrees, minutes, and seconds? This is the example. I have a latitude 320. Okay. In order to calculate the degrees, 320 divided by 69 is 4.63. Okay, this is 4 degrees. 4 degrees, okay. 4 degrees is equivalent to 276 miles. 320 minus 226 is 44. Okay. Right now, I have 4 degrees, and this difference, 44, will be used to calculate the minutes. And 1 minute is equivalent to 1.15 miles. 44 miles will be x, and x is 38.26. Right now I have 38 minutes. 38 is approximated 43 miles, 43.7. 44 minus 43.7 is equal to 0.3. This is the amount that I am going to use to calculate the seconds. 1 second is 0.02 miles. How much is 0.3 miles? Is x. And x is 15 seconds. Okay, finally, 320 latitude is equivalent to 4 degrees, 38 minutes, and 15 seconds. This is a perfect example how to convert this latitude into degrees, minutes, and seconds. Because 1 degree is 69 miles, 1 degree is 69 miles, 1 minute is 115 miles, and 1 second is 0.02 miles. This is only for information. You don't need in the future calculate the degree, the minute, the second. because right now the GPS calculates everything for you. This is only for information. I want that you know how the cell phone that you have in your home, in your hand right now, avoid that you calculate. You don't need calculate, because the computer of the GPS calculate those degrees, minutes, and seconds with more accurate, with too much precision. Ready? Okay, the GPS and the autopilot. A vessel course is much more accurate when an autopilot is working than the compass. 20 years ago, the information on the computer of the autopilot was coming from the compass. That the system was good, but it's not accurate. Too much deviation. Today, the information to calculate the final point is coming from the GPS. It's perfect. The deviation is practically 0.00 something. It's nothing, because the information is coming from the GPS. And the GPS calculates those degrees, minutes, and seconds that we calculated before with better precision. Alright? A compass specified heading keeps the vessel bow pointed and in a particular direction. However, the wind and the current produce a lateral drift that result in that the boat arrive not exactly to the destination, arrive a little close. With the GPS input, the autopilot will stay on the cross track perfect. Yeah, because the information coming from the GPS is more accurate. How does the GPS communicate with the autopilot? That's the most important part. How the GPS is communicating with the computer of the autopilot. Okay, the GPS and the autopilot essentially have a conversation. The GPS sends the signal and the autopilot receives the signal. The GPS sends electronic sentence down, and two-wire interface enter into the autopilot. Yeah, for that reason, if you check the connection in between the GPS and the autopilot, there are two wires, the wire that you have on the screen right now, and those wires enter in the computer according with the color code exactly in those positions. And right now, the GPS is integrated with the computer of the autopilot. There are other GPS that can be connected directly into the backbone. Yes, if they have the feeding to introduce directly in one terminal of the backbone, they should be connected directly to the backbone. Be careful with the drop line distance, no more than 6 meters. All right. For that reason, it's better if the GPS is connected with the back of the screen. If you check in this screen, the screen that we have on the picture right now, you have a special connector for the GPS, and that connector is connected with the sensor with the GPS antenna. In other words, it's better connect the GPS into the screen, because normally the cable, the sender in between the antenna and the screen, that distance is more than 6 meters. Yeah, in order to avoid excessive attenuation in the backbone, the recommendation is connect the GPS antenna into the computer of the autopilot, or directly into the main screen, into the computer or into the main screen. This is the recommendation, and this is the most difficult part of the autopilot installation, of the GPS installation. And once again, the autopilot depend directly today. The relation is a direct relation in between the GPS and the autopilot system. In other words, without the GPS, the autopilot is not working, because all the information, all of the calculations today in the computer are based from information from the GPS. 20 years ago, the computer depend directly from the compass. No, today the compass is a good reference, but the GPS provide the precision, the precise information in order to operate the autopilot perfect. The autopilot use this information to adjust the heading of the boat to remain on the cross track. Be careful with the distance of the drop lines. But in general, the GPS are connected with the sentence NMEA 183. With GPS input, the autopilot will stay on the cross track or the line in between the starting point and the waypoint of the trip. Connectivity. The hardware connection between the GPS unit and the computer is by the ports. The port that you have on the screen right now and the cables. This is the connection. The cable used is a two-wire cable. One wire is used for data from the GPS, and the other one is used for grounding. For that reason, the color codes are the cable that you have on the screen right now, two cables for data, and the other one for grounding. Some GPS units use three wires cables. With the added wire is for data transmission, and the other is for waypoint or map uploading. Yeah, there are other cables, GPS cables with three terminals, two for data, and other one is for map uploading. Yeah, this is very, very, very common. All right, how does the autopilot works? When the boat turns off or the reference course is changed, the autopilot should apply the helm in a way which brings the boat back to the course. Okay, how the autopilot do that is basically because the autopilot receives the signal from the GPS, compare that signal with the signal storage in the computer, and if the difference is if there is a difference, immediately send the signal to the servo cylinder, and the servo cylinder move the actuator. The servo cylinder correct the deviation on the arm of the rudder arm, and the boat is steered in the properly direction. All right, this is the situation in order to control the steer of the boat. At the end, the element that corrects the deviation is the servo cylinder. The servo cylinder could be electro servo cylinder or electro hydraulic servo cylinder, like the servo cylinder hydraulic that you have on the screen right now. The correct rudder angle depends on the amount of the error, the speed of the boat, and how the rudder is, how the servo cylinder is installed into the rudder arm. This is very important. In order to customize the autopilot, it's necessary setting the autopilot. When you start the autopilot at the first time, it's necessary that you put the rudder in 0 position. You do the rudder in 0 position, and you adjust the settings at that 0 point. That should be the 0 point for the rest of the calculations. Sensitivity. What is the meaning of sensitivity? The main task of the autopilot is to lock the heading of the boat to a predefined reference course. This is the course the boat has been when you press the button. Okay, what is the meaning of that? If the automatic mode, if the boat is working in auto, if in automatic, the autopilot constantly compares the boat's true heading given by the compass with the wished reference course in the same way that any control system. If there is a deviation, the autopilot applies power to the steering system, and the rudder turns the boat and gets back into the track. the rudder angle is fed back to the system. The element that adjusts that angle on the rudder is the servo cylinder. The servo cylinder. Okay, of course, the fluid is critical. The system, the power steering system, should be working perfect, soft in both directions, with any bubbles, no bubbles, and with the fluid in good condition, and with the pressure of the system on the reservoir exactly according with the recommendation, with the manufacturer recommendation. Fluid from the hand unit is first delivered through a sequence relief valve with protect the circuit from overpressure, assists in air purging, and provide the automatic transfer to the manual steering when it's necessary. Yeah, this is it. I explained to you before the procedure to bleed the system and the procedure to keep the power steering system in good conditions. This is the picture that we studied before in relation with the typical boat with power assisted unit, and this is the reservoir. This is the power assisted unit. This is the cooler for the oil. This is the servo cylinder, and this is the steering cylinder. Those cylinders are connected together in the rudder arm. With the servo cylinder receives the signal from the computer of the autopilot, and the computer of the autopilot receives the signal from the GPS antenna. The GPS sends the signal to the computer, and the computer corrects and sends the signal to the servo cylinder, and the servo cylinder adjusts the steer of the boat. This is exactly the procedure to operate the autopilot. For that reason, this connection in between the antenna and the GPS and the computer should be properly connected. The cable should be properly routed, separated from any other equipment that introduce too much electromagnetic interference. Electromagnetic interference is the enemy of the sender. This is the sender. This is the unit or sensor. This is the computer. This is the computer, and this is the actuator, the servo cylinder or actuator. All right. This is the construction of the autopilot system. The servo cylinder sends the current location of the rudder relative to the direction that you want to steer the boat, and direct fluid from the power pump to the steering cylinder to alter the course in that specific direction. The fluid output from the pump is measured and controlled to ensure sufficient flow and a smooth steering operation. Yeah, this is exactly the procedure to activate the pump and the cylinder. When the course correction has been achieved, the servo valve is neutralized and the fluid returns into the reservoir. Circulating fluid from the power pump is cooled through the heat exchanger. You remember, it's cooled and keep clean clean with the heat exchanger and the filter. I explained that before. Okay, your autopilot will work with either wet car or flush gate compass, doesn't matter, both of which respond to the Earth magnetic field. They also respond to any other magnetic field in the boat, including the engine block and the electrical circuit. For that reason, I recommend install this element, the compass. I recommend to you install the compass as lower as possible in the center of the boat. As lower as possible in the center of the boat. Right now I am going to explain what is the meaning of that. This is the compass. Your autopilot will work with either a wet car or flush gate. Yeah, this is the compass, and right now I am going to explain what is the meaning of the flush gate compass. The flush gate is also called heating sensor. It's exactly the same. Flush gate or compass or heating sensor. heated sensor. The flux gauge is one kind of magnetic field sensor which combines good sensitivity with the easy construction. In comparison with the magnetic compass, the flux gauge compass is more sensitive to the movement of the vessel in rough conditions. Yeah, it's better. Where should be located? Okay, if you check, this is the keel. This is the keel of the boat, and you see you have a hole here. This is the keel. This is the keel, and the water circulates here in order to be drained through the bilge pumps. And look at this. This is the center of the boat, and this is the bottom of the boat because this is the keel of the boat. All right. In this area should be located the flux gauge, and the flux gauge should be located vertical. The arrow here, like the arrow that you have on the screen, should be located pointed up. Okay, in this area, you don't have any AC power cables. You don't have any lighting protection cables. You don't have any antenna cable. This is not good. This is the enemy of those elements is the electromagnetic interference. For that reason, the compass should be located in the cabin, never in the engine room. The block of the engine, the block of the generators, the back end of the generators, the battery chargers, the inverters, those elements produce excessive electromagnetic interference. Also, the compass should be separated from air conditioning equipment. All right. To prevent magnetic interference, it should be placed sufficiently distant from big mass metals, engines, block, and AC circuits. Other comparison is the rate compass versus the flux gauge compass. A rate compass is a compass plus a rate of turn sensor. The flux gauge gives an accurate absolute heading free of drift. The new product, the last version, is the rate gyro compass. It's a combination of rate compass and flux gauge together. Yeah, the new Autopilot, they have an integrated rate gyro compass. The rate gyro compass integrates the flux gauge with the rate compass. The computer, this is the computer that we talked before, and this is the central computer, the central brain of the Autopilot system. I explained in details before the connection of that computer, and the rudder sensor, and all the connection. Operating modes of the Autopilot. The Autopilot operates in 3 different modes: in manual, in automatic, and in GPS. Okay, in the standby or manual position, the Autopilot is not controlling the steering unless given a command by the operator to steer to port side or starboard side. Depend of the human decision. In manual mode, the Autopilot is standby and the boat is under manual steering. The display show on the display manual heading. All right. The automatic mode. In the auto mode, the Autopilot will steer to a specific heading or course. In the auto mode, the Autopilot is activated and steers the boat to the reference course according with the information on the display. The reference course will be the course the boat has been auto mode selected. Navigation mode or GPS mode. In the navigation mode, the Autopilot gets starting information from a separate GPS unit. All the Autopilot with GPS connected for navigation can follow a track to a distance bearing and can follow a route of multiple waypoints and automatically turn to a new reference course when switching to the next waypoint. The GPS navigator should be compatible with the standard NMEA 183. automatic mode versus navigation mode. In order to accomplish this, the autopilot must be connected to an external GPS. Yeah, the GPS is the brain of the system. In order to work in the navigation mode, the autopilot should be connected to the GPS. Today, all the autopilot systems are working together with GPS. And when the GPS is not connected or improperly connected or not receiving signal, it's immediately the autopilot, the display of the autopilot present the alarm, no GPS, and you need to solve the situation. Other autopilot equipment is the wireless autopilot system. The wireless autopilot system is a good solution for small boats, but it's not perfect, it's not accurate. Depend of the signal, depend of the weather, depend of the receiver, depend of different factors. We are going to check right now this one in particular. This is an example. This is the Raymarine S1000. There are other ones. Each manufacturer have your own wireless autopilot, and every day are better, every day are more accurate, every day are more sophisticated. But if you have the chance to install a wire autopilot system, it's better than the wireless. This autopilot, in this particular example, the Raymarine S1000, is designed for hydraulic steering vessels, maximum 25 feet in length. Right? This is considered a small boat. All right, and the S1000 wire controller is a two-line display with a graphical autopilot status indicator. That one. Raised profile on a standby button for easy identification on the dark. Yeah, it's nice. It's designed for in order to be connected in a typical power steering system. With a capacity in between 5 to 8 cubic inches. All right, and this system is compatible with the following systems: with the a.c.r HC 5345, with this one, with this one, with this one, with those other systems, Bay-Star, and with those other systems, Hynotic K6. Additionally, the S1000 can be adapted to work with many hydraulic steering systems from different manufacturers like Vidus, Uflex, Lecam, Smith. Yeah, it's compatible with the majority of the hydraulic system. Okay, guys, now we are going to do the summary in relation with the installation of the autopilot. And we are going to check how to integrate the hydraulic mechanical system of the power system, the power assisted unit or hydraulic unit, the servo cylinder, the main screen of the autopilot system, the computer of the autopilot system, the antenna, the GPS antenna, the main screen of the NMEA backbone, the main screen, the main computer, and the sensors, the rudder sensors, and the flush gate or compass. We are going to check what is the procedure quickly and some recommendations in order to install properly an autopilot system. Okay, first step when you install an autopilot system, check your power steering system. How is your power steering system? Verify if you have a reservoir. If you don't have reservoir, my recommendation is install a reservoir. The procedure is in series. You need cut the lines. Originally, those lines, port and starboard, are connected here at the port and starboard side of the cylinder. This is the steering cylinder. Okay, you cut it, you remove those lines over there, and right now those lines enter in the input of the reservoir. After that, you fabricate two additional lines to enter into the power assisted unit, and after that, two new lines to enter in each side port and starboard of the actuator. This is the system, and verify that the fluid is the properly fluid at the properly level. Verify that the pressure is according with the manufacturer recommendation, is around 35 psi, and verify that the connection for the pumps are properly connected. If this power steering system assisted unit is properly connected, properly wired, and verify if the battery properly connected. Okay, right now my hydraulic system is good, and my steering cylinder is properly connected. Here is located the arm of the rudder, like you have on the screen right now. And in each side of the arm enter the servo cylinder in one hole, and the steering cylinder. The steering cylinder is activated by the wheel, by the hand, and the servo cylinder is activated from the computer of the Autopilot. That's very important. Okay, the servo cylinder is connected here in the position A and B of the computer, and the computer receives the power A and B directly. I recommend bring directly the power for this computer from a breaker on the sub panel. One breaker dedicated for Autopilot system, and that breaker provides the power for the computer, and that breaker provides the power also for the a.c.r power assisted unit for both of them. Okay, and yes, the power, and now the sensor. The rudder sensor should be connected in the position rudder according with the color codes, and the heating sensor should be located in the center of the boat, in the lowest part of the boat, in a dry area, pointed up. It should be located vertical, because remember, inside of the sensor you have the gyroscope, and the gyroscope should be pointed down all the time. And this one should be connected in the position flush gate directly. In the position flush gate directly according with the color codes on the computer. All right. Right now, this computer is connected. This computer, the computer of the Autopilot, is connected with the main screen, and the main screen is connected directly into the backbone. In other words, this computer and my Autopilot system is connected with the backbone. All right. Important that the power for the backbone, I have two sources of power, one at the beginning and other one in the middle. This one in the middle. In between both of them, no more than 8 amps. For that reason, I need fuses in the positive cable of each source of power of 4 amps in order to avoid more than 8 amps in the backbone. And I need to verify that all the drop line should be no more than 6 meters. I need to verify that I don't have more than 50 equipments connected into my backbone. I need to verify that my voltage drop be no more than 1.5 volts, my voltage drop. And this is the procedure to connect the Autopilot system. I have 2 screens. One screen, this screen about 2 connections. One connection for power and other for data. And I can use both of them. I can use this one or I can use this one. Yeah, in this particular case, I can administrate my Autopilot system with 2 screens. One screen on the flybridge and other main screen on the pilot hand. This is exactly the procedure to connect the Autopilot system. The servo cylinder unit could be like this, electrical 12 volts, or hydraulic, like the unit that you have on the screen right now. Thank you very much.